Hey there! Today we're going to look at an algebra problem that, honestly, seems almost too easy to be interesting. But don't be fooled, there's a really clever twist hiding in plain sight, a sort of mathematical trap that actually tells us something super important about the rules of the game.
All right, let's dive right in. The most obvious way to tackle this is to just follow the standard rules of algebra, the stuff we all learned back in school. So here it is, 1 plus a equals a. Just take a second and look at that. What's your first instinct? If you're anything like me, you're probably thinking, okay, let's just get the variable a by itself. So let's go with that gut feeling. We'll subtract a from both sides of the equation to keep everything balanced. This is classic Algebra 101, right? On the left, we're left with just the number 1. And on the right, well, a minus a just cancels itself out. And we get 1 equals 0. Now, hold on a second. Unless the fundamental laws of the universe have just decided to take a day off, this is a major problem. It's a flat-out contradiction. It basically screams at us that this equation is impossible, that there's no solution.
So is that it? Do we just throw our hands up and say, no solution, case closed? Or could there be another angle here? Maybe another way to look at this that might give us a completely different result. But what if we're just not using the right tool for the job? Let's hit rewind and try something a little different. A bit more unconventional. And this, my friends, is where things start to get really interesting. This time around, we're going to pull out a more powerful algebraic tool. We're going to square both sides of the equation. Now, this is a perfectly legal move in algebra, but as we're about to find out, it's one you have to be pretty careful with.
Okay, follow me on this. When we square both sides, things change quite a bit. The left side, 1 plus a squared, expands out. And look at that, we now have an a squared on both sides of the equal sign. How convenient is that? They just cancel each other out, which leaves us with a much, much simpler equation to solve. A little bit of rearranging, and we've got a all by itself.
And just like that, there we have it, a nice, clean, definitive answer. Using this squaring method, we found that a equals negative 1/2. Looks like we've totally cracked it.
But hold on a second. Let's not celebrate just yet. We got a clean answer, sure, but remember our first attempt? We ended up with a statement that was impossible. Something here just doesn't feel right. In math, you're never truly done until you've checked your work. So let's plug our shiny new answer back into the original equation and see if it actually works. So is a equal to negative 1/2 the real deal, or did we just get tricked? There's only one way to find out for sure. Okay, this is it. The moment of truth. We take our solution, negative 1/2, and we plug it back into our original equation. 1 plus a equals a. The right side is easy, it's just negative 1/2. On the left, 1 plus negative 1/2 simplifies down to positive 1/2. And there you have it. We're left with the statement that positive 1/2 equals negative 1/2. And that is absolutely 100% false. Our so-called solution is a fake. It completely falls apart under scrutiny. So what on earth just happened? We used valid mathematical steps, we did the calculations correctly, but we still ended up with a phantom solution. Where do we go off the rails? Well, what we have just discovered is something that mathematicians have a pretty cool name for, an extraneous solution. You can think of it like a ghost. It's an answer that appears during your calculations, it looks totally real, but as soon as you try to check it against the original problem, poof, it vanishes. So where did this ghost come from? The culprit was that squaring step we did. You see, when you square both sides of an equation, you can actually lose a really crucial piece of information. You lose the sign. The difference between positive and negative. Just because two numbers have the same square doesn't mean they were the same number to start with. Here's a super simple way to think about it. If you square negative 2, you get 4. If you square positive 2, you also get 4. See? The process of squaring completely hid whether the original number was positive or negative. It created a false match, a false equivalence, and that is exactly what happened in our equation. So let's boil this all down. What are the big lessons here? Well, first, our gut feeling from the very beginning was correct. The equation 1 plus a equals a really has no solution. Second, you have to be super careful with powerful tools like squaring because they can introduce these phantom answers. And third, and this is probably the most important rule of all in problem solving, always, and I mean always, check your work. It's your ultimate defense against being fooled by these mathematical ghosts. This whole thing really makes you think. If an equation as simple as this one can hide such a clever trap, it makes you wonder,
What other simple-looking problems are out there that have a beautiful hidden twist just waiting to be discovered?